This table is probably something you're going to want to have memorized when you go to the AP exam. I would add it to your formula sheet once you get your test booklet and you're able to write in it, because it can get really confusing to interpret type 1 and type 2 errors, as some of you experienced trying to do this Dorito question. So I wanted to apply the Dorito question to this table. All right, so there's a truth about the population. Either the null hypothesis is true or it's false. Those are the only two options. And then there's a conclusion we're going to make based on our sample. If the p-value is low, lower than whatever our significance level is set at, in this problem our significance level is 5%, if that p-value is low, we're going to reject the null hypothesis. If the p-value isn't lower than our significance levels, so if the probability of obtaining our sample isn't less than 5%, we will fail to reject our null hypothesis. So that means there's only 4 possible outcomes. Okay, so let's examine this first box. Hypothetically, we know the truth about the population and the null hypothesis is true. Well, if the null hypothesis is true and we reject, that means we made an error. We rejected something that was true. And this is what's called a type 1 error. So in this Doritos problem, a type 1 error would be we reject the null hypothesis that the true proportion is 0.12, when in fact the true proportion of Americans that do favor the Doritos ad is 12%. Okay, now this question didn't ask for a possible consequence. On the AP exam, they would specifically ask for a type of consequence. On this, Doritos might spend money on getting a new advertisement because they didn't think their first one was successful, because they believe Americans didn't really like it. So the company might spend more money in new advertisement. That might be a consequence of this type 1 error. Also, remember, the probability of committing a type 1 error is whatever you set your significance level at. That's that alpha level, whatever your significance level is set at. So the probability of rejecting, well, we gave a 5% level of rejecting. We set that. The researcher set that. The problem set that. Okay. Now let's look at the next scenario. Suppose the null hypothesis is true and you fail to reject. This would be a correct decision. Okay. Now let's look at what if the null hypothesis is false. The null hypothesis is false, but we get a p-value that tells us to reject the null hypothesis, right? These are conclusions we're making based on our sample, based on our p-hat. Remember, the p-hat from this was that 64 out of the 623. So our p-hat was about 10.27%, okay? So if the p-hat yields a probability that is lower than alpha, we're going to reject. But if it turns out that that was a false, that the null hypothesis was false, and we rejected, did we make an error? No. No. This, again, would be a correct conclusion. And this is called power, which I'll get to again in just a moment, right? And then lastly, the null hypothesis is false, but we fail to reject based on our sample. Our sample, our p-hat, doesn't give us a p-value. I know that's so confusing, the p-hat and the p-value. I'll try to do more to clarify that later. Our sample doesn't give us evidence to reject our null hypothesis, so we don't, but it turns out the null was false. That is a type 2 error. And a type 2 error, the probability of a type 2 error is what we call beta. Using that notation. Okay, so a type 2 error here would be that the true proportion of people who favored the advertisement is actually less than 12%, but the Doritos company fails to reject the claim that it's at 12%. And so maybe they keep using an advertisement that wasn't effective. That could be a possible consequence. Remember, consequences don't always have to have this severe negative connotation to it. It's just what would be a result of making that decision. So let's look at this probability of a type 2 error and probability of power. Remember, they are related. So our null hypothesis was that P is at 0.112. But then we've got this new value, this truth, that it's actually at 0.085. Okay, so we draw in this new curve. This is on the back of your worksheet. Okay, that's now centered at 0.085. This is the true parameter, hypothetically speaking. Now, I want you to remember something from this problem. We set our critical value at a 5% alpha. So our Z star at a 5% alpha gave us a critical value of negative 1.645 standard deviations below the mean. Okay, so if you go back, if I want to find out just what percentage that would be, that means any p hat that's at 10.16, I just used inverse norm to find this, any p hat that's just at 10.16, so a p hat that's at 10.16 or lower percent, we would have rejected. This is our alpha zone in green. Okay. But we didn't reject because our P hat was right here. Our P hat was 64 out of that 623. This is about 10.273%. So that's why we failed to reject the null, okay? So by doing that, we made a type 2 error, okay, because we were just given the enlightening evidence that the true proportion was at 8.5%. So what we are being asked to calculate here is the probability of making that type 2 error. Well, the probability of making that type 2 error is set by this critical value. Making a type 2 error is based on the idea that we fail to reject. Think about what we just talked about. So what I'm going to look at here, and this is going to be a little bit confusing, is the area where I would fail to reject this original claim, that 12% claim. The area under the new curve where I would fail to reject. So anything to the right of my critical value on the new curve is the area where I would have failed to reject. So what I'm being asked to find, and this is the beta. Here's our beta. Okay, this area under the curve represents beta. So if I go to my calculator and I want to calculate an area under the curve, this is a normal curve. We can do the checks and assumptions again. We're not going to work through all of that right now. So my lower value is whatever this critical value was. Okay, so I'm going to use, I can either go back to using z-scores or I can use this p hat value. It's really up to you. Okay, so I'm going to use I'm going to use the p hat. 10.16. And then my upper bound is going to be off to infinity on my new curve. So shaded off to infinity. And then my mean is this new proportion, P, 0.085. And my standard deviation is going to change because my standard deviation is now based on my new p-value. So square root of 0.085 times 1 minus 0.085 divided by our sample size is still 623. And our beta is 6.867%, so about 6.9%, which means our power is 1 minus beta. Now so here's the power of the test, about 93%. But I want you to know something, that the AP exam has only ever asked for you to actually calculate this value once. What you have to know how power and beta are connected.